Hello ladies and gentlemen, my name is Decryption and I hope you are well. So one big thing I've been planning for a while that we're going to look at doing soon is upgrading the AI in this game. I want to give them loads of features, and in order to do that we need a solid framework, otherwise it's going to quickly become very messy. So what we're going to do today is look at one of the ultimate AI frameworks, Utility AI. We're going to discuss what it is, and we're going to have a quick preview of what we're going to do, but it's going to take a few videos to actually create everything, but I'll still be able to show you what it is. So let's get started. So with Utility AI, it's typically a framework that you build top of it. So really it's a bunch of code and classes. It's not a very visual thing. So just like when I'm explaining a lot of things, we're going to jump over to Critter. Now, I didn't really like the white background before because it was very in your face when I'm on a dark mode of PC. So I've gone chalkboard style and we've got, black on white this time because it's a lot easier and nicer to look at. So what is Utility AI then? Utility AI isn't a piece of code you use, it isn't a plugin, it's nothing like that. It's a way of designing a decision-based system, and it works with anything. It doesn't replace state trees, it doesn't replace behavior trees, goal-oriented programming, none of that. It uses all of them. This is why it's so cool. So let's look at an example then. You have Farmer John here, right? Farmer John, we know he wants to walk over and he wants to play in his farm. There's his farm, And then every morning, Farmer John is going to walk over to his farm and do his business, right? But then we have an issue, because then two enemies approach. How can I make these enemies? I'll give them a sword. There you go. Two enemies with swords, kind of. So you have your two enemies here, right? And they prance on up to the farm. And at this point, you need to now make Farmer John here make a decision. He needs to say, do I need to defend my farm? Do I need to run away? It depends on his personality. And this is where it gets really cool. So what we do with Utility AI is we assign loads of tasks to Farmer John, right? We'll ignore the scheduled part at the moment. We'll just say, at any given time, we assign loads of tasks to him. His task is move to a location, farm on the farm, and then attack the enemies and run away. We'll assign 4 tasks to him. So the enemies, using Utility AI, walk to the nearest victim, right? And then on Farmer John, he makes a choice. He runs over every task and says, what should I be doing now? The first task, do I need to move to this location? Well, no, I'm already here. So that will return a very low score, if not just no score at all, 0, because he's already there. Should I be farming this? Well, technically, yes, he should be farming. So we'll make that return just a medium score, like 0.5, 100, whatever you want, right? So 0.5. Let's make notes of this, actually. So excuse my poor handwriting, I'm a programmer, not an artist. So move, does he need to move? No, he's already there, so he's got a score of 0 there. Should he be farming? Technically yes, so I'll put 0.5 just as a default one. You should be farming right now. But when this run away and the attack scores are generated or checked, the way you produce it is saying what is actually driving this task. So should he run away? Well, there are enemies, so we'll say 0.5. Yes, you probably should be running away. But then, in the same score calculation, we'll say, well, is Farmer John a coward? Is he a victim? Has he got combat experience? Whatever you want to say. Well, yes, he does. So we're actually going to minus 0.5 off of that as well. But then you could also say, has he got health? Has he got damage? How many enemies there are? Any choices. But we'll just say the grand total for run away is 0. Farmer John's not our type to run away. Attacking, well, you could say, well, Farmer John's going to defend his land, so we'll return a 1. And now, with all of this, when the choices are made, it'll come down and say, what's got the highest score? Well, attacking has. So at that point, where I should have named my layers, there we go, Farmer John will say attack, and the system will say to Farmer John, right, you run the attack task. That task can be made up of anything we want. State trees, behavior trees, a random blueprint, playing an animation, it can be anything. A task is just a blueprint, essentially, a piece of code. And this blueprint is going to say, play the estate tree, attack the nearest enemies, and he'll run up, take them both out, and then the enemies disappear. There you go. And then, because that task has been complete, it comes back to this list and says, hey, what do we do now? It'll come down and now say, hey, do you need to move to the farm? Well, yes, you're not next to the farm, so we'll set that as a 1. The farming one will say, are you at the farm? ready to farm? Well, no, so we'll press 0. Does he need to run away? No, there's no enemies. Can he attack anybody? Well, no, there's no enemies. And then now the choice is obvious. He will run to the farm, which will make him move over here, and then the utility choice decision tree thing will be ran again. So the move, do you need to move to the farm? No. Do you need to farm? Yeah, there's no enemies, I'm next to it. Run away? No. Attack? No. And now his decision becomes obvious. That is the core principle of utility AI. It's a choice-driven AI framework, essentially, because it's not a plugin. You can create it in pure blueprints if you really want to. And then you can expand it from there to any way you want. And all it is at any given point, when an AI needs to know what to do, it is given a list of tasks. The tasks return their highest score, and that's the task he does. You very well could have it where it pulls in 2 of them saying the same score. So say he has a 5th task of, I don't know, see the wife. And maybe that also pulls a 1 in, you know? Same as farming. You should be farming, but you should also be doing that. And at that point, you can decide what you want to do with it. You can either just make him randomly pick one, or you can make him go for the first one. Entirely up to you. You could even report it as an error if you only ever want to have one grand task, but you might run into a bunch of issues with that. Because the point of a score is it randomly changes at any given time depending on their circumstance. Like right now, he's next to the farm. The highest point is either farm or go see his wife. But if you add the enemies back into the mix, all of a sudden all of that changes. He doesn't want to farm because his enemy's nearby. He's not going to run away because he's not a coward. He's going to attack, but he may still want to see the wife. Maybe she's a combat veteran as well. You never know. But that's the key part of it. And of course you can expand this. So if we zoom out a little, and if we wrap all of those initial tasks in a schedule and say between the hours of 5 a.m. to 12 p.m., so 5 to 12, he'll do these schedules. But then your scheduling system will say, well, at the hours of 12 p.m. to 5 p.m., maybe he has a different set of tasks. And it might be plant the scarecrow or attack, you know, anything like that. And then they'll score them separately themselves there. And then your scheduling system can just change which active tasks he can score. So every time he says, hey, give me a score, it comes back to your system. It says, hey, which tasks do I need to do? Well, it's currently 1 p.m. These are my tasks. Plant the scarecrow, attack. That's it. And then you can add loads of specialist stuff around there on task end, on task begin, all stuff like that. This system we're going to build as well, and it is a very common way of doing it, is you also have the ability to add dynamic tasks. So let's say that these enemies here actually did come in, and Farmer John at the time was seeing Mrs. Farmer John. So we'll give her some luscious long hair under her hat. There you go, Mrs. Farmer John. He was in the house seeing Mrs. Farmer John. So he didn't notice that they've come and they've unfortunately set his farm on fire. You know, they've burnt it, it's all gone, upset Farmer John. But what you can do with it at that point is when Farmer John notices, or however you want to do it, if the farm burns, find some way to do it, you can come up and say, on the farming one, you can either remove the task entirely so it no longer is a contender to look at, or part of the scoring system for the farm is, does the farm exist? Because if it doesn't, then you could just outright return 0. That's it. And it doesn't matter if they've got 50 tasks. If all of them return 0 because he's not ready, he'll go with whatever option he has. And that's why utility AI is really powerful. So if you think of a game that has AI, you can mostly look at how they work to figure out what decision they're making. And yes, you could do this with tons of if statements, absolutely. But why? If you can make individual modular task files here, and then they all run little bits, that's so much easier to manage and balance. Because you've all seen the behaviour trees when they get absolutely huge. And of course I googled it and can't find one, but you know, this one's getting a decent size bigger, it's going to get even bigger, you know, whatever. If you build every decision your AI needs to make, imagine how big that would be if Farmer John had to check for moving, farming, running away, attacking, seeing the wife, you know, planting the scarecrow, attacking potentially again. But imagine all the logic all of that also has to contain in it. The move has to go to location or actor, it has to get the actor it needs to move to, has to wait for them to arrive there, and then it has to say I'm done, which goes back up. The farming has to play a series of animations. It's going to be huge. And this is a very small blueprint. Imagine it when you've got, you know, a huge AI. It's going to be crazy. And that's essentially it. It's the choice-based approach to designing AI in a really nice way. There are loads of extra features you can do. Everybody does it differently. For mine, I've got 3 types of tasks in mine. Scheduled tasks, which are at this time you should be running this. Default tasks, which are if you can't do anything, consider doing this. But in my case, I treat it as you might also want to do this. Adds it to the mixture. And then you've also got dynamic tasks, so things that have been added because of a quest, a dialogue or something. Maybe the player walks up to Farmer John and says, hey, do you want a new hat? Here's a new hat. And every so often he might walk around, do a little dance in his new hat, That's just another task we've added to the list. And what mine does, at least the way I've designed it, is it gets all the tasks he was supposed to be doing at that current schedule, it adds to a list all of the default ones and all of the overrides, sticks them all together, finds the biggest score and runs that one, which is a really nice way of designing the AI. So let's take a quick look at what we've done then. That is the basics of a utility AI. Let's take a look at it in action so you can see what I mean. So we're back in my game here, right? And I'm still slightly working on my utility part, just testing it, make sure it's all good before I put the videos out for it. It's going to be a couple of videos because it's a big one, so make sure you subscribe for when that does come out. But if I jump back over to my combat level here, because that's the one I was working on, we have the Warden here, right? On the Warden, I've added this NPC brain component, and I can add a schedule, always available tasks, which are the default ones, and the dynamic tasks. The schedule is literally just an array of periods, so between 8 and 9, do this task. For me, I've made a task called print debug. All it does is literally print out the words period 8 to 9, because that's what you're in. Between 9 and 10, it will print out a period of 9 and 10. You can do anything you want in these blueprints, attack, run a state tree, anything. I'm just printing out for debugging purposes. Default tasks, I've got one here, which is default debug task. That's it. But the scoring, you see, for this one, the base score is 1. They're all base scores of 1. And if we just come and open up the debug task, literally what it does is on execute, print this string, wait for 5 seconds and call finish task. And all finish task does is tell the brain to say, hey, go and reevaluate what you need to do. This could be on state tree finish, on animation finish, on death of somebody, anything like that. Back on the brain, the available tasks and dynamic tasks just literally let you add the task in there. But the dynamic ones have a few more abilities. You can remove them when they're finished. So if you had a one-time dynamic task, do a dance with your hat, score it really high, they'll dance straight away and then the task will be removed. Nice and efficient. We've also got an enabled one if you want to add a task to it and disable it for later use. That's an option. And when you add tasks, we've got loads of helper functions to reevaluate straight away, wait until it finishes, all other stuff like that, right? But let's take a look at it in action now. So when I start the game, I've built it in a way where it uses the game's world time by default, but I'm fully aware nobody will want that. Everybody's got their own time system. So part of the initial build is I've added this get current time function, which will let you simply use anything you want. So in my case, I'm grabbing the ultra dynamic skies current time, clamping it between 0 and 24. So if I play it now, the default time is 800. So if you look at the very top up here when I click play, nothing will happen, but it will print out periods 8 to 9 because it's between 8 o'clock and 9 o'clock. Period 8 to 9. And if we wait 4 seconds, the text will disappear and the next one will be reactivated. 8 to 9 up. That's the task he's doing repeatedly. If I come to Ultra Dynamic Sky, and we'll set this to 900 in a minute, so wait till it prints again. So it's in the middle of the task. I'll print again. The lights change, you see. He's on that task, but now he's gone to 9 or 10 because the choice in the schedule has said, hey, this is the task you're supposed to be running. If I press the 0 key, I'm going to add a new task to him, a dynamic one. And all I do is on debug key 0, get the NPC, add a dynamic task. And all I'm doing is adding a new one of dynamic text added. That's it. The base score is 1, but I'm forcing the selection right here. So this one will be picked full stop. So if I come in now, click play, you'll see if I press 0, the dynamic task has been added. So after period 910, it will say dynamic text added. And because I've told it to remove it when it's done, that will disappear. And now period 9 to 10 is back. And you see the decisions we're making as we add to it like so. So I've just made a super basic debug range task. It's essentially the same as this debug one, but I've overridden the score function, and I run the default score so it'll get 1 or whatever the player sets it to. But what it's going to do is get the NPC's location and check how far away from 000 they are. If they're more than 500, it's going to add 1 to the additional score, giving it a higher boost. Whereas if it's false, then it'll just use the default score. I was going to do it based on the player's location, but I need to build that functionality in because at the moment you can't do get player pawn or anything like that. But I'm going to build that in because that's going to be so much nicer. But now if I use this task instead, if I come to the schedule here and see this debug task here, I'll add another one to between 8 and 9 and say debug range. And I'll say I should go to the farm. And I can leave everything else. I've built gameplay tags into it and all of the stuff like that. But I'll leave it just as it is like that, right? And we'll save it. If I play it now, he's just printing out period 8 to 9 debug, like that, yeah? Because he's close to the centre. But if I grab him and move him away 500 units, he's now printing I should go to the farm, look. Because he's moved away, I should go to the farm. So if we move him back, because that's scoring higher, it's printing the correct one. I think it's messing up slightly and printing twice because I'm moving the location here. If I could run up and budge him out the way, I don't think it would be an issue. But I haven't built that in yet, so I can't. But you can do it any way you want, and that's the system we're going to be making soon. I'm not selling it unless enough of you tell me to sell it, but we're going to build it anyway because it's going to be really cool. It's a lot to learn, but it's going to be so worth it. You might be thinking, what started all of this off, if you generally are. I was working on my latest hide and seek video, and I ran into a big issue. I wanted to simply walk up to this NPC, speak to him. After the dialogue finishes, he walks down here, and then plays some more dialogue, waits, and then plays the hide and seek sequence. And I wanted to make this really generic because that's going to be the better way to code it. If you make everything generic where you can, your game gets a lot easier to design. And yes, I could have just added an event saying play dialogue after going to location, but then it's playing dialogue after you go to location, starting a wait sequence, and then, you know, going to play another state tree. It's a lot of work to chain that all together. Whereas with the task system, I'd literally just add 5 tasks, scoring them higher than the rest each time, or one at a time, it doesn't matter, saying go to this location, wait 5 seconds, blah blah blah, and he'll go boom 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 and do them. Very, very cool. So there we go, ladies and gentlemen, that is what utility AI is. You very well may see plugins saying they support utility AI and all this other stuff. They may very well support it and, you know, build it based on that principle, making it really easy for you to do. One of the key plugins I know that uses it is Narrative Pro. It's what taught me what utility AI was in the first place, absolutely, but this is a much simplified version where you can customize it for your game really nicely. If you're building a system with even a half decent AI, I absolutely recommend it. There are plenty of other ways of doing it, but utility AI is just such a nice framework to head towards it. So thank you for watching, ladies and gentlemen. I hope that was helpful. If you are looking forward to the series where I put it out, I can't remember when the video's coming out, but I've got some other tweaks I want to do to it yet just to make it a little bit nicer. I want to maybe look at adding an editor timeline so you can see the times easier, but yeah, we'll look at all that. But thank you for watching, ladies and gentlemen. If you would like to see this series early, there is a Patreon link below. For as little as £1, you will get early access to this entire series as soon as it's ready, far quicker than when it comes to the social platforms, and all the money goes to supporting us, so I thank you for that. But thank you for watching, ladies and gentlemen. My name is Decryption, and I will see you next time.